Okay, thank you. So one of the questions people wanted to see was some more dimensional analysis. So that was when I was reviewing the homework and I was reviewing what everybody had. We're looking at dimensional analysis. So let's look at our fundamental units. So we have fundamental units of length, time, mass, and there are others, but this for General Physics 1, we're going to do mostly in length, time, and mass. So length could be in meters if we're using SI units. If we're using English units, this would be feet. Time, we're lucky because that's seconds and that's seconds. Now mass is going to get a little strange. SI units are kilograms and English units is a weird unit called a slug. And this is because these are fundamental units. Weight is a force. Weight and mass are not the same thing. We have a force acting on a mass, which gives us weight. And when we do that in SI units, this is going to give us something called a Newton. And in English units, this is a pound. So if we're looking at an equation, so let's take velocity, for example. Now, velocity is a vector, which means it has direction and magnitude. All right. Velocity is not necessarily speed. Okay. Velocity is not necessarily speed. And this is where things get into a little bit of weirdness. But velocity is defined as a change in position with respect to time. Speed is also, we have a position versus time, and this would have units of length versus seconds. Or if we're doing this, this could be in meters per second. This could be in feet per second. It could also be in miles per hour. All right. So if I'm using my dimensional analysis, I know that this is going to be in units of length versus time. So if we're doing it the way the book did it, we're using length versus time. So if I had something like mass times velocity squared, my units would be in mass units. I would have length squared divided by time squared, and that would give me my dimensions. Now, where this all comes into play is, let's say I'm having something that travels 100 kilometers per second, and I want to know what that is in miles per hour. Well, first thing I'm going to need some ones so that I can do my conversion. So give me a second here because I want to make sure I don't use the wrong number. Now, in the appendix of your textbook, you will also have conversion factors. So 1 kilometer is equal to 0.62 miles. So if I want to convert kilometers to miles, I'm going to use my 100 kilometers per second. I'm going to have my 0.62 miles on top. And that's 1 kilometer. I'm going to use my unit analysis to get rid of this. And now I'm going to be in miles per second. I'm going to get my handy dandy calculator out. And I'm going to do 100 times 0.62. And that's going to give me 62 miles per second. But I want it in hours. So I'm going to have to do a conversion there. So we know that 60 seconds is 1 minute. And we know that there are 60 minutes in 1 hour. So now I'm going to get my 6,200 or 62 miles per second. Those will cancel, minutes will cancel. Now I'm left in miles per hour. And that means I'm going to get 223,200 miles per hour. So the unit analysis is just verifying that my units make sense. So let's look at an equation. So this equation has mass times velocity is equal to 1/2 mass times velocity squared plus velocity times time. And we want to know if that's dimensionally correct. Is this an equation that I could actually use and make it dimensionally correct? Well, in this case, I have mass times length divided by time. This one, I don't have to worry about the 1/2 because there's no units on the 1/2, but I have mass times length squared divided by time squared. Then I have length divided by time times time. Well, those are going to cancel. These things are not equal. That equation is not dimensionally correct. And because of that, we know we've done something wrong. We can't use that equation. That equation's not right because I can't add those things together. On your exam on Thursday, you're going to have a set of questions that say, are these things dimensionally correct? It'll be one question, but you've got like 4 parts. And it'll be essentially doing just something like this, which you've done already as a homework problem. You've done it already as a quiz problem. So you can expect one of those types of problems that you have out there. I'll double check something. There we go. Yeah. So you want to look at that part. So hopefully that answered someone's questions about dimensional analysis. Anybody have another specific question on dimensional analysis before I stop recording and then start recording again? Okay, seeing none, we're going to set up